The fundamental theorem of arithmetic. While numbers have an infinite number of multiples, they have a finite number of factors. In fact, there are whole numbers that only have one or two factors. Prime numbers are whole numbers which have two factors, themselves and the number 1. Here are the smallest prime numbers: 2, 3, 5, 7, 11, 13, 17, and so on. Take a moment to see why the other numbers between 0 and 17 are not prime. 1 is not a prime number since it has only one factor itself. Remember, prime numbers have two factors. 4, 6, 8, 10, 12, 14, and 16 are not prime since they all have 2 as a factor. So, for example, 4 has the factors 1, 2, and 4. So it has 3 factors, therefore it's not prime. Actually, no even number greater than 2 is a prime number. That's the only even prime number. 9 and 15 are not prime since they have 3 as a factor. All of these numbers except 1 are called composite numbers. Euclid, a Greek mathematician, proved that there's no largest prime number in 300 BC. But mathematics is unable to predict the prime numbers. A very large amount of money, time, and electricity is spent using large computer server farms to find new prime numbers. This is done since large prime numbers are key to cryptography. The product of large prime numbers is easy to create, but very difficult to factor. It makes a great key to encode information that can't be read without knowing the prime numbers used to create it. Cryptocurrency mining involves finding more prime numbers and then using them to create unbreakable code. It involves vast, powerful computers that use a large amount of electricity, contributing to global warming. The largest published prime number as of January 2018 has over 23 million digits. It was calculated by multiplying 2 by itself 77 million times, over 77 million times, and then subtracting 1. No doubt, many larger prime numbers have been found since then, but they are hard to find in the public domain. Keeping them secret is a matter of commercial and national security. Examine the number line below. Which numbers on the line are prime? The only prime numbers on the number line below are 2 and 3, which are circled. 0 and negative integers are not prime numbers, since they're not positive integers. 1 is not a prime number, since it has only one factor. 4 is not prime, since it has 3 factors. So 2 and 3 are the only ones that have exactly 2 factors and are positive. The smallest prime numbers are 2, 3, 5, 7, 11, 13, and 17, and so on. In this course, when we reduce numbers to prime factors, we will rarely need to check prime factors larger than 11. The fundamental theorem of arithmetic states that every integer greater than 1 can be represented as a unique product of prime numbers. That unique product of prime numbers is called the prime factorization of a number. So this is also called the unique factorization theorem or prime factorization theorem. The prime factorization of a number has many applications, as we will begin to see in later units. Factor trees are useful in finding the prime factorization of a number. Let's find the prime factorization of 12. Alright, so first we're going to check for prime factors one at a time from the smallest prime number, 2. So the result of dividing 12 by 2 is 6. So we write those on the same line. So 12 is 2 times 6. 2 is prime. It is a prime factor of 12. So we're done here. However, 6 is not prime. So we are going to have to factor this. It's even. So the next step is to take out another 2. 6 can be rewritten as 2 times 3. 2 and 3 are both prime, so the factoring here is complete. So what we're going to do is we're going to circle all of the prime factors at the end. Then we write the result. So the prime factorization of 12 is given by 2 times 2 times 3. You could also write that as 2 squared times 3. 2 times 2 times 3.